So, good morning, everyone. Today we are going with next levels that what we have studied in last period. Sorry, sorry. So we were studying some physics topics. So I think we have studied till the sound and then with that we have studied about the sound force, Kepler's law, universal gravitation. So this much we have studied in our last period. So we will continue further. Like till today, we are going to uh, start new topic that is light. Light. The characteristics of light. We note down the what is light? It's a form of energy. It is a form of energy. Second thing, it has dual nature. One is wave wave nature and particle. That is photon. Smallest particle are photon. Call it as photon. The light waves form, in this case, light wave forms transverse wave, transverse wave. These can travel in any medium like in vacuum also, and we can polarize them. Now the nature of light, whatever it is we have discussed, light it has a dual nature, a form of energy, and can travel in vacuum and liquid, gas, like this. And the another phenomenon of light is reflection. Reflection. When the light gets reflected, when it get a smooth surface, with the help of smooth and polished surface, light gets, light bit. Smooth polished surface. If light is coming from here, it reflects back. So in this, the first light which is coming, the first rays of light which are coming, we call it as this one we call it as incident rays. Incident rays. And this light which reflected back, that we call it as reflected back, reflected rays. Here they make a angle I. This is normal. Mm, Angle of incident is always equal to angle of R. We know that. And these all are always lie on same plane. Like angle of incident and angle of reflection and normal always lies on same plane. Now we will discuss the mirrors. Mirrors. Mm. There are three types of mirror. First one is plane mirror, spherical mirror. In spherical mirror, we have two types of mirror. One is concave mirror. Sorry. Another is convex mirror. So we call the concave mirror also converging, converging mirror. And we call this is as a diverging mirror. If you remember this. Like this is the spherical mirror. First, we discuss plane mirror. I will tell you about first plane mirror. In plane mirror, like this is a plane mirror, and this is an object. In this plane mirror, the what does the plane mirror phenomena shows? Like the distance between from here, distance from object to mirror. This distance, this distance, these two distances always equal. A, B. A, A equal to B always. And the size of image is always same. Size of image is always same. This shows the lateral inversion. Like the left hand of this object, like left side of this object will be right side of this object in the right side. Okay, and right side of this thing is in left side. So this shows lateral inversion. Another thing, when an object moving from here to here, then the object coming to near to the mirror will be, if the speed of object is, then the speed of image is coming to object will be to you. With respect to object, the speed of image will be to you. Only and speed of image will be only you. But with respect to object, it will be to you because object is also moving and image is also moving with same speed. That it will be two times of speed. So these were the characteristics of the plane mirror which we see during the image formation. Now we will further discuss about the concave and convex mirror that these are the spherical mirrors. Like how these spherical mirrors are look like. Like this is spherical mirror like that. This is the line. This is actually concave. This is the reflecting surface. reflecting surface. So this curved inward. Inward. In convex, it is also like same like in convex. In convex are curved outward. Means they are bulge out. They are like wall shape. They are bulge out. So the some signs which we draw during the study of these mirrors, like this is a concave mirror, like this. In this concave mirror, this is the this line we call it as principal axis. Principal axis. In this distance we call it as focus. And this is the equal to twice of this is called center center of curvature. This is focus, and this is center of curvature. Okay, and, and this is these are the if parallel light coming from, then it comes to the focus. This is focal length, and this is the center radius of curvature. This coordinate is also radius of curvature. Now we will discuss few things for the mirror. Uh, the center of curvature is equal to twice of focus. Okay. Length of curvature is always twice of focus. So the types of images which the mirrors they form types of images formed by the mirrors are real mirror, real image, virtual image. So what the nature of real image? on screen. On screen. This is virtual image. Count of frame. Boundary of frame. On screen. This image is called a on. Not from inverted image. Also called inverted image. This we call it is erected image. All virtual image are erected image. These are characteristics of the images. So we will discuss image formation of concave mirror in cases and its cases. Image formation of concave mirror. Step first case, we can draw like this. Object, then obtain image, nature, image. This is if object is at if object is at a infinity, like this. If object is coming from infinity, then the parallel light comes in and it go to the focus. Then after that image is it will be image obtained image where at focus. Nature of image will be real, inverted, and extremely काफी छोटी रहेगी diminished बहुत छोटी रहेगी because this will form here only. So in second case, it was first. In second case, if image is beyond the beyond the center of curvature, like this. When it comes to the focus, another parallel line go from here, it will come here. So this will form here only. So it will be between image often here between focus and center of curvature. Nature of image will be that will be also real, inverted, and diminished, not highly diminished. Very small, it will be diminished, not equal to the object. In third case, at center. At center, then it is here. Then the object will this will go from this side and it will come to the focus. Here to come to focus and go there. And from here, one light will come coming from focus and it will reflect back to here. So this will form here. So the image will be obtained where center of curvature at center only. The size of the image nature that is real inverted. The real are inverted only and equal to object. If now another case, if image between focus and center of curvature like this, if it between focus and center of curvature, like this is image, light come here and it will go here. And another light comes from here. And this will go here like this. थोड़ा सा missed. Like this, it will go like this. And this light coming from here, this will meet here. Is that is beyond the beyond the center of curvature. So image will be at beyond center. The size will also a real, inverted, and bigger than object. If it case, if it will be at focus, at focus, like this. If it is at focus, Like this is object. In light, it will go from here, and this will go parallelly back. Same in this case also, parallelly back. So the image will be at infinity, and it will be extremely magnified. If it is between pole and principal axis, in focus. Focus, this is pole. If image is at this position, then the image will form will be this will go like this in one ways go beyond the mirror, and from center the another light will go from here. So this will be beyond the behind the mirror, and the nature of image will be virtual, erect, and magnified. Okay. So these were the six cases of the uh, concave mirror. So we have discussed like if it is at infinity, then it will come to focus. In all case, we find that the mirror image is always real and inverted. In some case, it is diminished. In some case, it is equal to the object, and in some case, it is smaller to object. And in only last case, if object is placed between focus and principal, then image will form beyond the mirror, behind the mirror, and that will be virtual, erect, and magnified. Okay. So, now we will discuss about the concave mirror or convex mirror. In case of convex mirror, we have we have only two cases. In first case, if object is at infinity like this. This is the convex mirror. If object is infinity, then this will coming from here light ray. This will go here. This light will go here. This focus behind the mirror. So the image will be at focus behind mirror. And the nature will be virtual and real. In the second case, if it is between focus If it is between infinity and pole, like this, then image will form at then the image will form at between focus and pole behind behind mirror, and it will also virtual and erect. But this is diminished. In this case, the image will be very small, diminished. In this case, image will be very small. That is extremely diminished. We have studied their cases. We need to remember in exams they ask about this uh, one of the case. They want to the nature of the image. Sometimes they ask the image obtained. So in this case, the in concave mirror we find that mostly the images are real and inverted. That is also called it as a real concave mirror. In convex mirror, you always find a virtual direct image. Now we will discuss some formula, that mirror formula. Mirror formula. In mirror formula, it is 1 plus 1 equal to 1 X. This is mirror formula. Magnification for magnification. The formula is height of image is equal to height of object is always equal to minus image length of image upon length of object. So this we call as height of image. This we call it as height of object. In case of U, we represent U as a object distance. We call it as a object distance. And we represent Y image distance. F focal length, R is with the period of curvature. In focal length, For concave we take minus sign. For convex we take plus sign. And always r equal to 2f. And we take object is object. This we take always negative. Negative. For this is the distance. So the object is always placed in front of mirror only. We now discuss the uses of mirror. What the uses of these mirror? Concave, concave mirror. For what purpose we use concave mirror? It is for magnifying, for saving. We call it also saving mirror. We use it in torchlight. But it always gives the bigger image. In saving, we that was sixth case. Sixth case. Case that it gave the magnified image. Magnified. Okay. Also, dentists use this mirror. Used in solar furnaces. Now it is convex mirror. Uses of convex mirror, like they give you diminished image, or we will use for the diminishing image. We use it as a for the rear view in cars and vehicles. View mirror, like in ATMs, because it covers large area. Sunglasses, reflection in street light. So we use here also. So we find that the concave mirror is magnifying image, magnifying mirror. So for the saving purpose and dentist, to see the large image, so we use the concave, and in convex, it covers large area. So like it diminishes the image. So rear view mirror in vehicles, ATM, sunglasses, reflection sunlights. So we use for this purpose. Now we are going to discuss another phenomena of light that we call it as reflection of light. Refraction of light. Reflection of light. If this is a, there are two mediums. One it is called as a like this is a water. We can say this is a water. One minute, one minute. Let me draw correctly. This is a water like the water. And this is air. So there are two mediums. First ones are the light rays coming from air and it is going to the this is normal. This is the normal. So light rays incident lights coming from rare medium and they go to the water like this. This is all. These are called reflected. This is also normal. So this medium is called as rare medium. We call it as denser medium because water is more heavier than air. And in this case, what we have observed, what we have observed that light rays which were coming from rare medium, when it goes to the denser medium, then they went towards the normal, towards the normal. So the angle of incident is always in this case greater than angle of arc. So this is the phenomena whenever light changes their medium, then it changes its path also. It's a deflection path. If it would have gone from the denser to rare, then angle of like in second case, if there are two medium like this is a denser, this is the rare. In this case, if the light was coming from this denser to rare, then it would have gone away, went away from normal. this case, they went away from normal. So the angle of incident is smaller than angle of R. So in denser, it bends towards the normal. In in rare, it bends away from it's away to the normal. Now laws of reflection. Laws of reflection. In this case, same like in reflections cases, the normal angle of incident and angle of reflection are all lie same plane. And this sine incident angle is upon sine refracted angle is always constant. For the given two particular, I would say medium, given two particular medium. So in this case, the this is important that sin I and sin R equal to constant, and the it bends away when the it comes from denser to rare and bends towards when it comes from rare to denser. Now, further we will discuss about refractive index. Refractive index, it is usually represented by the m or mu. So the ratio is that is speed of light in air or vacuum. Vacuum is speed of light in given medium. तो इसमें क्या रहता है refractive index is always to the ratio of speed of light in air or vacuum. That is, speed of light is 3 into 10 raised to power 8 meter per second and in given medium. So we can write it as BQ. So it is the speed of light in light of light in air and it is in medium. The few respective index we will tell you like in air it is 1.53. Refractive index of light in air is 1.003. In ice, it is 1.31. Alcohol 1.36. The most highest of them is in glass. It is 1.52. And in case of some solids like in diamond, only difference will they are in diamond it is 2.42. So they have these are the few important ones that which can be asked in exams. Now we will study about lenses. Now the lenses. So these are the spherical lenses. There are also two types. One is concave lens, second is convex lens. They usually form the image through the refraction. This is the important point. Forms image through refraction because the medium get changed because they are solids, not like mirror. They do not reflect back. So in this case, the refraction usually occurs. So in concave, they are bulge out. Sorry, they are concave are inwards. They bulge inwards. And convex are bulge out. In these these are called as converging lens. Because of this, these are called as diverging lens. These are opposite of mirrors. Mirrors, the concave mirror were we were calling as diverging, and the convex we were calling as converging. But in this case, convex we call it as diverging, and it is the concave is converging. The image formation. So we will not draw the any picture here of that particular positions. We will only discuss the positions of particular planes. It will take too much time. So the image formation will conclude in convex lenses. In first case, the position of object. In this case, position of object. Here, position of image. Nature of image. In first case, when the object is at infinity, and the image will be formed at focus. The nature will be real, inverted, and highly diminished. Second thing, if it is between infinity and instant of curvature, then image will be at between f and 2f. It is also inverted and diminished. In third case, if it has 2f, then the image will be at 2f, means it's like a center case, and it will be real, inverted, and same size. In this case, if it is between f and 2f, then the image will be beyond 2f. It has real image. It's in this case, if image is at f position, then it will the object is at f position, then the image will form at infinity, and it will be a real, inverted, and enlarged. If image is beyond f and between f and o, then it will be at the image will be at on the same side of the lens. It will be virtual, direct, and enlarged. And we will discuss image formation by the convex by the concave lens. By concave lens. The concave lens, if image it at infinity, then image will form at f, nature of image virtual interact highly second case if object between infinity and 2f, then the image between f and 2f, it will be real, inverted, and equal. Infinity and principal. Then it will be between focus and principal. Then image is always virtual. In this case, image is also always virtual. Correct. Right? Diminish. So now we will discuss about the uses of mirror. कॉनकेव मिरर किसके लिए यूज करते हैं? वो मिरर्स ऑफ लेंसेज कॉनकेव लेंस किसके लिए यूज करते हैं? द ट्रीटमेंट ऑफ मायोपिया. इन ट्रीटमेंट ऑफ मायोपिया, करेक्टनेस ऑफ इमेज मतलब इमेज को करेक्ट करने के लिए. कॉन्वेक्स किसके लिए यूज करते हैं? कॉन्वेक्स लेंस कॉन्वेक्स लेंस यूज करते हैं इन ट्रीटमेंट ऑफ हाइपरमेट्रोपिया. Used as a magnifying lens. Used as magnifying lens in cameras in camera lens. Now another feature that is power of lens. What is power of lens? Power of lens is equal to 1 by focal length. So the focal length is always measured in meter. So the SI unit will be meter inverse. That is also called as diopter. Diopter SI unit of power of lens. Case of in case of convex, it is plus. And in case of concave, it is minus. You need to remember this. One last concept that we are going to discuss in this chapter. Light diffraction. What is diffraction? It's a bending of light. Bending of light around the corner of an obstacle. So this is called as diffraction. So we will discuss the defect of eyes. When least distance vision is least least distance of distant vision equal to 25 centimeter. What we are going to discuss the defects of eyes. What are the defects? The first we are going to discuss that is myopia. Myopia. That is also called as nearsightedness. Nearsightedness. In this case, what happens? The focal length decreases. आइज की फोकल लेंथ डिक्रीज हो जाती है फोकल लेंथ decreases power increases image form in front of retina इसमें क्या होती है इन फ्रंट ऑफ रेटिना पहले ही फॉर्म हो जाती है इमेज फॉर्म इन फ्रंट ऑफ रेटिना पहले ही फॉर्म हो जाती है उसकी ठीक है सो हम इसको करेक्ट करने के लिए क्या करेंगे वी डू नॉट एबल टू विजिबल बिफोर what we use in this case we use minus power lenses that is concave concave lens we use concave lens in hypermetropia hypermetropia that is also called as for sadness. In this case, the object cannot be nearby object can't be seen. Nearby objects can't be can't be seen. In image form behind the retina. What happens? Image form behind the retina. Light focuses behind the retina. So what we do for correction? Correction we use positive lens, power lens that is convex. The image behind the retina होगी, then we use convex lens and its focal length is more, then the power will decrease and the power will decrease, then image will come on retina only. So power decrease होगी इसमें and retina. Okay. Now another thing that is press myopia. In press myopia, what happens? Lenses hardens with age. What they do, they lose flexibility. Focus after the age of 55, 55 plus. Correction, what the correction we usually give here, what the correction we use in place by concave and plus convex. Both lenses we use it because in place by sometimes the focal length comes before and after also. So there are few few points which regarding to eyes which we are going to discuss here, like what is glaucoma or trachoma, why this has happened. This happened because of increase in increase in pressure in eyes. आई में प्रेशर की वजह से होता है. ग्लोकोमा में क्या रहता है? इज हेयर विटरी. ट्रोकोमा में क्या रहता है? इज बैक्टीरियल इन्फेक्शन. So they are not curable. Okay, they are not curable. What is tonometer? The one device that measures the ice pressure that is called as tonometer. Tonometer is which helps to measure the eye pressure. Eye pressure. That we call it as tonometer. Tonometer. Another thing that is color blindness. It is hereditary. So why this is happen? Because of uh, absence of cones, retina cone, cone cell, and rod cells are absent in this case. Now reflection, dispersion of white light in glass. What they give you color? Light consists of seven colors. So seven colors. What are the seven colors? If light goes from here, in this case, light coming from here, and it goes here, like this, and it comes back to here. So these colors are red, orange, yellow, green, blue, indigo, another color is violet. So this is this color is less deviated. ये less deviated होता है. Therefore we use in traffics and all, so that we can able to see it. इसकी high wavelength होती है. Wavelength is high. More wavelength. ये इसमें क्या है? Wavelength decreasing. Decreasing हमेशा याद रखना है. This is more deviated. Because of that, we are not able to see the color of the sky more deviated. In case of speed, in red color is more. In red color, speed is more. In case of violet, the speed is less because its wavelength is more and it is directly proportional to its speed. Few things like twinkling of stars because of this is because of due to effect of the earth damage, earth atmosphere. Okay, so this is occurs reflection of atmosphere because of reflection in atmosphere. Okay, one phenomena is total internal reflection. Internal reflection. This phenomena is responsible for optical illusion, optical illusions. Examples like what are these? Like mirrors, optical fibers. In this condition, they should always travel. What are the conditions? In this, light should travel from denser to rare medium, and light should hit an angle greater than critical angle. These were the few things we have discussed here. Now we will now we will discuss another topic, that is electric current. New chapter, that is electric current. What the electric current? It's a flow of flow of charge per unit time. So it's I equal to Q upon T. One electron is equal to 10 raised to power minus 19 coulomb. SI unit will of charge is coulomb. SI unit of charge. Q equal to number of electron. One coulomb is equal to n into 16.6 into 10 to the 19 coulomb. N equal to 16 to 10 raised to power 18 electron. It's measured by measured by ammeter. SI unit of current SI unit is ampere. In this case, we know that like charges repel each other and opposite attracts. And the material like conductor which conducts the electric conductors. Inductors are there, allow, allow electrons to flow. Insulators not allowed, not allowed. Okay. What is the volt? That we also called it as potential, potential difference. Potential difference, it's a amount of charge, amount of work, amount of work in moving a unit positive charge from one point to other, other in an electric field. So this can be written as work done upon Q. So this volt is measured through the voltmeter. And SI unit is volt. It is also written as 1 volt equal to 1 joule upon 1 coulomb. Another thing that we are going to discuss is Ohm's law. What is Ohm's law? Ohm's law is current flowing in a conductor is directly proportional to the voltage across the conductor. What is Ohm's law? Is V. Ohm's law is volt is directly proportional to current flowing through it. So we can write it as V equal to IR. R is a resistance. You know that. And the SI unit of this resistance is ohm. That we write it as like this. This is symbol. Now the few factors which affect the resistance. First one is like take length because in this case the resistance formula is like length upon area. This is the resistance formula. If length will increase, then resistance will also increase. Second case, if area of cross section is increased, then If area of cross section increase, then resistance will decrease. Third case, if temperature is increased, then resistance also increase. So this is called resistivity. Resistivity or specific resistance. SI unit of this resistivity is mho or ohm minus. This can be written as equal to meter per meter square. So this can be written as meter resistivity. This is the SI unit. One thing is alloys has has greater resistivity than its constituent particles metal. Okay. Types of matter like conductor, we have studied the flow of, we call it conductor, and has been left, that was the semiconductor. That is just some semiconductor, not fully, not fully. Examples are like glass, wood, in this case, iron, silver, in this insulator like, sorry, these are the example of wood, insulator in wood है, glass है, they are the example. In this case, silicon, gallium, these are the example of semiconductor. And when resistance connected in series and parallel, series में resistance करेगी तब, then like this resistance, this, at that time R1, R2, R3, like this. When total equivalent resistance will be R1 plus R2 plus R3. In case of parallel, if resistance are connected in parallel, like this, then R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3, like this. In series, what we find, in series, what we find, same current and different potential. Current do not change. Same current in all resistance, different different voltage. In parallel, in case of parallel, same potential and different color and different current. Heating effect of current. Heating effect of current. What heating effect of current is? That like power is equal to work done upon time. Then electric, it is equal to work done upon V equal to this much. It is equal to QV upon time. Then the heat equal to electric power is equal to VI. What we can write it as this VI. Okay. We convert it later. Then it will be like when it is like power into time equal to work done. Then it will be like VIT. And we can write it as also I square RT. Practical appliances applications of heating up. Practical applications are like bulb. In bulb, filament made up of tungsten. So the melting point is high, but do not melting point is high. Coil heater. In coil heater, it is made up of nichrome. Nichrome that is alloy of nichrome and chromium. In fuse, it has low melting point, so it get break down when there is more heat easily. Electric power, that is P equal to VI, that is equal to R I square R. The commercial unit of power is, we know that commercial unit क्या रहती है हमारी of energy, it's always equal to 1 unit. हमारे घरों में मेजर करते हैं वो होते हैं 1 किलोवाट, 1 किलोवाट आवर. So this is power into T, and this is 1 kilowatt is equal to 1 kilowatt is equal to 1000 watt. So this is equal to 1000 into second. So this will be 336 into 10 to the power 5 watt second. So this will be 3.6 into 10 to the power 6 joule equal to 1 unit. Okay. 1 unit. So the actual voltage and the frequency which we are using, that is standard, is 220 watt and 1500 in electric appliances. And there are few things. The live wire we, that is रेड को बोलते हैं, एंड न्यूट्रल में होता है जिसमें वो क्या रहता है हमारा, ब्लैक रहता है. These are the small things that can be asked in exam. एंड ग्राउंड के लिए, अर्थिंग के लिए क्या रहता है, अर्थिंग का कलर क्या रहता है, ग्रीन होता है या फिर येलो होता है, ग्रीन येलो. You need to remember this all those things. So चलो आज हम एग्जाम करते हैं. Further we will discuss next class new chapters of physics and whatever, chemistry and biology. After that, history and geography. We will cover all these syllabus. Thank you. And Jai Hind.